Okay, so am I audible?
Yes, sir.
Okay,
Yes, sir.
so I'm sharing the screen. So I mean, in the last class, we were discussing about the adjustment methods. So in principle, what we were discussing is that we were having a least square module or a model which we have to use right from the last class, because we knew that what is the least square model does. It says that sum of squares of the residual. Please remember these are the residuals that has to be minimum. So we are doing the summation of squares of the residual to be minimum. And at the same time, what we are doing, we are thinking that how these residuals are going to be prepared. So by our first class definition, that means the definition which we have taken in the first class, suggested that Vi is nothing but Li minus MPV. That means for any observation, uh, its deviation from most probable value is Vi. But anyhow, we have still not clear about the definitions of MPV, most probable value. So we just taken the L bar or the mean, or simply mu L as your one of the estimate for the true value. So MPV is obviously in general is considered as the mean as the most probable value if you have observation for N. But in the second domain, what our adjustment approach says that instead of MPV, you need to find out the adjusted observation. Instead of saying that it is a mean value, we are more focused of saying as LA, which is the adjusted values. Now the reason is very simple to tell you about this is from very basics. You could assume that for a triangle, if you are saying alpha 1, alpha 2, alpha 3 are the three observations, internal angle observation for a triangle ABC. And if you are writing this equation alpha 1 plus alpha 2 plus alpha 3, and it should be 180-degree, but in fact it is not. Why? Because these are the observations that you are observing using some angular devices or angular measurement instrument. But these are having errors. Okay. Why they are having errors? You all know that because there are various type of sources, various type of errors are there, because of which these errors are there. And if we try to devise some mechanism, or we try to
अमित,
uh,
अमित, सुनो, ये बीच का दरवाजा बंद कर लो, बाहर से बंद कर लो उधर से।
so what we were thinking is that if we have uh, adjusted one observation is prepared some way or another, that means these values are adjusted and they are given in new values. How? Through some mechanism. Still we are not sure which mechanism we could discuss at present. Some may say if the misclosure error is 3 seconds, we probably distribute it to 3, and then 1 second correction could be applied to all these angles. There may be one approach, but still we are not very much sure that this equal distribution of error is the right way of doing it or not. Okay, there is one way. Second is, if we could devise any another method or some specific criterion by which we could get this adjusted value, then there is a possibility that the summation of these adjusted value would lead to 180-degree. But another, this is one option. Second option is people would say that we take multiple measurement of alpha 1, multiple measurement of alpha 3, and multiple measurement of alpha 3. So let's say it is n time, it is p time, it is t times they have measured, and then we are writing mu of alpha 1 plus mu of alpha 2 plus mu of alpha 3. There is also chance that it would not go 180-degree because of the reason that if you are committing error in alpha 1 and the nature of error you do not know, then these type, if you take n observation or p observation or any number of observation, the chances of that source of error cannot be removed. Okay, that will always be there. So in this case, the mean of individual observation is not solving our problem, which we were doing it here. That means we are trying to use this method that, okay, the residual is nothing but the individual observation minus most probable observation. So that's why this first approach, we need to think over it, that how we can devise a mechanism by which we could adjust the observation. It is about adjusting the observation. That's why this approach would not lead to anywhere. But again, we go to the first one, this one line. So this is one discussion that we were having in the previous triangle problem when we were discussing the introduction to adjustment, the need of adjustment. So this is just little summary. Anyways, coming back to this problem, so the residual which we are having is Vi, which is nothing but Li minus MPV, or we could also rewrite this equation as LB minus MPV, and LB is nothing but the raw observation. We are more focused on the raw observation minus, instead of MPV, now here onwards we'll use the word LA, which is called adjusted observation because that falls better into our category. So this raw observation minus adjusted observation, or you could also see that this adjusted observation is coming after the adjustment procedure. So our one of the objective is to estimate this at the same time. In this MPV, we do not have this intention that we will estimate the MPV. Instead, we have this intention to take the mean as the most probable value. But in this case, switching from MPV to LA doesn't emphasize that we are still having the LA. LA is will be treated as unknown. So this is the approach that will be used here in this observation equation model. So for observation equation model, we are in your last class we have taken some certain notation. So V is residual, LB is raw observation, LA is your adjusted observation, and X is your vector of unknown. Let us write the dimension first. I'm again repeating. V is your residual, LB is your raw observation, LA is your adjusted observation, and X is your parameter. So if you see, you do not know, these are unknown. Only this is your observable, which is available to you. So you have this the so-called system of least square module, in which I have told you there are three systems. One is observation equation method, another is condition equation method, and third is mixed model. So we are first studying this observation equation model. So our objective is nothing but to have a system where you are inputting the sigma, the LB and sigma LB, which is, this is your nothing but the raw vector. This is your raw vector, and this is your the VCV associated with your observation. Okay, that is going into this observation equation model, and you are achieving the XA which is the parameters, sigma XA, which is the variance covariance matrix of adjusted observation, and LA as well as the adjusted variance covariance matrix of the observation. So you are just ensure that what you are inputting in the system, you are just entering the raw observation, you are just entering the variance covariance matrix into this system, and in fact what you are getting this adjusted parameters, the variance covariance matrix associated with your adjusted observation as well as the variance covariance matrix associated with the the adjusted observables. So I'm again repeating this term: residual matrix, raw observables, adjusted observation, or this is also known as parameter, or I would use XA at the adjusted parameter. There should not be confusion that X should be further adjusted to XA or not. So it is directly we are getting the adjusted parameters. I hope there would not be any confusion. If you are having any confusion, just let me know. But it is very simple. The model is very simple. You just need to understand the basics of it. Okay. And this observation equation, again, least square solution has only one basics, which is summation of squares of the residual is to be minimum. In matrix form, it is VTPV, it's to be minimum. That's it. We do not have any other function that would goes and make as the basics of your observation equation or condition equation or mixed model. This is the what should I say? This is the your thumb rule for which you are doing this adjustment, because this is only you have read in your understanding the so-called um, while finalizing that which adjustment method you would choose. Again, those who are still not sure that why we are moving with the adjustment, let me just again remind you that if you have observation, your approach up till 12th, what was there? If you are given with 10 observation and your purpose is solved with 5 observation, your approach is to use those 5 observation to find out the X. But this approach will not help you in this geoinformatics domain. Okay, our approach is that is there any way so that we could take in all 10 observation in a system or a black box which you should know about, and then you come out of a single X. Okay, this is our approach. We have to follow this approach in our geoinformatics domain. So we have taken one example and we have shown that if you take pairs of 5 observation or 3 observation, you will get different X, which is not the right way of doing it. So we have to develop a system where we have to take in all, not only 10, all observation. Okay, that all observation goes system and a single X would come out. But again, as a geoinformatics professional, our purpose will not solve only with a single X. What we need associated variance covariance matrix every time. Why? Because if you remember our previous few classes where we were studying about error propagation, we were always giving you the observation plus associated variance or standard deviation, and we demanded about the this. So we gave you the observable value as well as its variation, and it is expected that you would get the X, but it is there would be some errors. So that's why we do not recommend any solution with only X. We want X supplemented with its variance covariance matrix at the same time, because we know that these observations are erroneous, they have the errors. That's why they are called as observables, because they are observation containing or behaving as a variables. That's why they are called as observables. So they are having errors, that's why we want to adjust it. associated with adjusted variance coherence matrix rather than using the raw variance coherence matrix we want to find out. So though in general, our objective is to achieve these four: XA, sigma XA, XA, LA, sigma LA. If we achieve this, our purpose is solved. Okay. So again, I'm just revisiting those aspects which we have covered in the last part. The reason is very simple because with the nomenclature, if you do not write it from your mind, it is not possible to get the whole picture out of it. Okay. So with this, I mean, our this background, we understand that our objective is now to develop that development model because of in the formation of observation equation method that we have named our method. But first you need to understand that how this observation equation model would look like. Okay, because we all know that from your geoinformatics methodology which we have studied in previous classes, there are certain steps, and in one steps after the measurement you have to form the mathematical model or adjustment model. Okay, that step maybe probably fourth step, I guess. In that fourth step you have to develop the adjustment model, and that has to be based on least square solution, and that least square solution is again of three types. So we are reading this first type which we call it observation equation method. But how what type of model is known as we should think of that when we should approach the observation equation model, because we have to decide or we have to make a rule when we'll go for observation equation model, when we'll go for condition equation, when we'll go for mixed model, isn't it? So for one by one, we'll start with observation equation model that takes the shape as A, or better way of if you write in vectors. So if your function or a problem which you read from your given question or any kind of situation, the moment you read the problem, in your back of your mind, you think of possible mathematical model that would fit in, possible mathematical model that would fit in that problem, isn't it? The moment you read problem, if it is a trigonometrical having trigonometrical orientation, you immediately find equations, supporting equation that would solve the purpose, or the so-called sine rule, cosine rule. These kind of rules automatically comes to your mind. So these possible mathematical model would automatically come to your mind because of your background. You have mathematical background with you. These models would automatically come to your mind, and probably you have to identify that which of the model takes the shape like this. Means fxa is equal to la is kind of situation where that means on the left hand side you would have parameters, and on the right hand side you will have observables. This situation would be there, just like h is equal to d sine alpha. H was the xa, this was the la. So there is a proper separation. Okay, so there would be certain cases where I mean chances would be there that you would have a proper separation. Okay, but some cases would also be there where you could not be possibly bifurcate like this. Then a situation would come. Then once you finish this all three methods, you would probably know that which way to go ahead. So initially, we start with this method, which we call it as observation equation method, where we start with fxa is equal to la. Okay. Now the first approach is now you are aware that it is a fxa is equal to la. Okay. And you need to understand one more point is that whatever we are doing, it is for doing for linear systems. Okay. In fact, I have told you in the last class, we have linear system of equation. Okay. That we have to attempt for. So we will make sure that our model should fall into this category of linearization. If it is a non-linear function at first, it should be linearized. So linearization is a thumb rule. You should not get confused that linearization should be done or not. No chance. If it is a non-linear, first equation is non-linear, you immediately have to linearize it. Or if you're not able to linearize it, then that means you have to find out a non-linear solution that cannot be found out by least square solution. Okay. So this is very straightforward rule which you have to attend. Okay. So having said that, you have a model which is nothing but fxa is equal to LA. Now, as I've told you, for linearization, you will use Taylor series expansion, which you have done in during error propagation. We'll go for Taylor series expansion and with respect to initial point. So we have chosen, we have chosen initial point because function is with respect to so-called xa. So we'll choose the initial point as xa is equal to x naught and linearize it. So how do we linearize? We choose the function value at x is equal to x naught plus partial derivative with respect to all possible variable, then their value at the chosen, then xa minus x naught is equal to. Obviously, we are ignoring higher order term. Then on the right hand side, this written as LA. Now here, one more food for thought. That means the equality sign will only exist. This equality sign, which we are, highlighting here for preparing the function, this equality sign will only hold for adjusted values. So if you try to see, I've used XA and LA on both hand side. It is not true if you take the raw observation. Please remember always. This is for you to remember every time that you will always form the functions or possible mathematical model with adjusted values, not with the raw values. Okay. Obviously, that's why they are models. They are not the solution. You have to use them to get the solution. Okay. So for, while preparing the function, you have to use the adjusted values. Okay. If you think that your purpose would get solved with X and L, then probably you would not be reading this domain or not expertise, because if this is true in real world, then everything is done. No need to study all along with errors and everything. In fact, in reality, this is not true because no raw observation can satisfy this model. That's why we are moving with fxa is equal to LA kind of model. Okay. So again, just for your memory, so that you always remember, must remember that you will prepare the model, you will think of the model with adjusted values. In fact, we'll take a lot of examples today that would be much more beneficial for you. Okay. Then you need to understand that this is the left hand side which you have uh, prepared. Here you have a full constant value, as you can see. Here also you can see there is a constant value, maybe C1, C2 you could identify. This would be delta X, or simply if you multiply the individual component, one with this, another with this, then you will get a whole multiplicative picture. But instead, for the time being, we just using that this as a delta X, C2 delta X. On the right hand side, as I've told you, LA is written as LB plus V. This is a corrections or residual that is applied to raw observation, then only you will achieve the adjusted value. So LA is nothing but LB plus V. V could be positive, V could be negative, that would come out after the finding the solution. Okay. So here, let's say if we are going with particular notation that we have to adopt later on. So we will use this word as C, and this proper nomenclature, which is, let me just again draw so that to avoid any confusion. This partial derivative part is we know as A delta X. So we are writing LB plus V as A delta X plus C. This is our equation, or V is equal to A delta X plus C minus L, or V is equal to A delta X if we take minus out of L minus C naught. If you take C naught is also a good choice to choose. Then we'll write V as A delta X minus L, or better word is L. So these are the 5 steps which you need to understand. First, this, second, this, third, this one, and finally you achieve the linearized solution associated with, this is your linearized solution, V is equal to AX minus L. So you started with this f of xa is equal to la, isn't it? You started with this because that you thought as a possible mathematical model which would fit in your problem. Then after linearization, you achieved at v is equal to xa minus. This is the linearized version of this. What is this v? Again, residual vector, because we are working in matrix system. A is called as design matrix. This is your adjusted or adjusted parameter, you directly say. Or if those who have seen how this delta x converted to x, they could also probably say as uh, uh, correction to adjusted parameter. Because probably some of you would write it as, in some of the literature, this step is directly coming as this, but in some literature they would probably use with x, this delta x as x. But no need to worry, they all are same. If you consider as correction, you will go with delta x. If you directly choose the parameter, you will choose. This L is somehow different, and it is called as LB minus C naught. Okay, so we do not give any values to or name to this, but it is simply the so-called correction to raw observation. So residual vector, design matrix, adjusted parameter, and correction to all. So this was the first step. If we could achieve, given the non-linear model, if we could achieve the linear model, that is one way. I'm just scrolling back to top just to make sure that for your better understanding about the matrix size. Here, I'm just highlighting so that you probably correlate with what we are discussing. Here, the size of LB is known as the initial raw observation. How much size is available? So we are saying it is n cross 1. That means n vector of raw observable is available. The same is getting adjusted, so there would be no change. There would be again n cross 1. Then you have parameters that would be, sorry, it is not mu, it is in fact u cross 1. It means parameter size would be u cross 1. Now my question, because you have probably listened to it for half an hour, more than half an hour, what would be the size of residual vector?
Sir, 1 cross 1.
N cross 1.
1 class 1, sir.
Good. We are getting replies. That means you are all focused and listening. That's great. Again, think again. Probably one of you would be right, but probably all should approach and give us the solution. सुधीर आप बताएं. Sudhir, are you there?
Sir, he is not there in class, sir.
Okay, okay. चलिए सुनील सुनील बताइए आप बताइए.
यस सर.
क्या साइज होगा?
n क्रॉस 1.
रुचि आप बताइए.
सर 1 क्रॉस 1.
और कौन बच्चा भाई? सभी लोग बताएं, क्योंकि उसके बाद जब सोल्यूशन बताएंगे तो आप लोग को तुरंत क्लियर हो जाएगा कि मैं क्यों गलत सोच रहा था.
सर 1 class
भगत
1 ही.
भगत बताएं.
n cross 1.
अभिजीत आप बताइए.
n cross 1.
N cross 1.
और कौन बच्चा? वैली शेट्टी आप बताइए. तो जो लोग n क्रॉस 1 बोल रहे हैं दे आर राइट. जो लोग 1 क्रॉस 1 बोल रहे हैं दे आर रॉन्ग. अब बताइए 1 क्रॉस 1 कौन बोल रहा था?
सर प्रवीण.
प्रवीण एक हो गए, सुमित हो गए, और Sudhir, you there? Join.
Sir, actually, I am in meeting, sir. One. Sir.
Okay.
Hello.
Hello.
Sir, I'm not getting your voice, sir.
Am I audible to you?
1 minute, sir. I will take earphone. 1 minute. I'll use earphone, sir.
Please.
Hello.
Yeah. Now is it audible
yes.
to you?
Yes.
So yes, I was asking about the size of the matrix of V, residual matrix V. What would be the size of V?
Sir, size of the V, like V is the residual error, and then LA is our NPV value, and LB is our raw observations, and X is our parameter. So based on that one, we'll.
So what would be the size of V?
It will be depend upon the observation, sir.
It will depend on the observation. Hello.
Yes.
It will depend on the observation, you said?
Yes, sir.
Yeah, that's right. That's what I'm confirming. If it is, if you are saying that it is based on the size of observation, that's right. Answer would be n cross 1.
Yes, sir.
Okay. Again, I was looking for the yes. Here I have just mentioned it. This one. I was scrolling down. In fact, it was written earlier. So VI is nothing but it is purely related with observation only.
Yes.
Okay, that's why it is related with the observation, and the size would be same. Now, those who are saying 1 cross 1 must have got confused with our last class discussion where we told that summation of squares of residual has to be a single value. Is it so, Sumit?
Yes, sir. It was.
Why? You must think before speaking that what has been answered, what has been questioned. In fact, this vi summation of vi square is an entity. Okay, that would, and its matrix version is VTPV. That
Yes, sir.
VTPV product is a value, not V. V is a n cross 1 matrix. Okay.
Okay, sir.
So probably all have answered. Is there anyone who's got left? Valley Shetty, is it clear?
Yes, sir.
Okay. So now I'm writing V. Sorry. This V. We have got LB. We have got LA. We have got X. Okay. So if we have got V, there would be sigma VV. If we have got LB, there would be sigma LB LB. There would be sigma LA LA, and there would be sigma XA XA. Now, again, I want the sizes for these VCV matrices. Please tell me. One by one, you can just say.
Sir,
For
N cross
sigma VV, we want. विशाल, आप बताइए. विशाल बताएं. विशाल.
Sir,
हाँ बताएं. The
sir,
size
sir,
of
these are
VCV.
observations. So value will be one for one each. One time we'll have one observation. Then after it will get added. So 1 cross 1.
Sorry, what you are saying? I could not get it. What you are trying to say?
So
What
sir,
first? Okay, okay. Before you speak anything, first you understand what is this. What is this? This is variance covariance matrix for residuals. Variance covariance matrix for raw observables. Variance covariance matrix for adjusted observation. Variance covariance matrix for adjusted parameters. Okay. Now you have to tell me the sizes. चलिए बताइए. बताइए विशाल, बताइए.
sir, I need some more time to understand, sir.
Okay, I get it. Now I understand because you have just joined in one class back. So
Yes, sir.
you just start reading the books as well as the slides that I've shared.
Yes,
This
sir.
is variance covariance matrix. यशोवर्धन, आप बताइए. साइज क्या होगा?
So n cross 1.
क्यों n क्रॉस 1 क्यों? जस्टिफाई भी करिए. सुनील, आप बताइए.
yes sir. Sir, N cross N.
ऐसे गेस नहीं मारना है, एक आंसर देना, उसको जस्टिफाई करना है. बताइए, टाइम मत लगाइए, जल्दी बताइए. नहीं आता है. शुभम, आप बताइए.
n cross 1 b residual
n
matrix.
क्रॉस 1। रुचि आप बताइए।
सर नहीं पता है।
राहुल।
सर 1 क्रॉस 1।
1 क्रॉस 1। शाबाश। प्रवीण।
सर n क्रॉस 1।
n क्रॉस 1। और कौन बचा? अरुण कुमार साहनी।
Sir, n cross 1.
n क्रॉस 1। सुमित।
सर क्रॉस n।
n क्रॉस n। अभिजीत।
Yes, sir. Sir, n cross 1.
n क्रॉस 1। भगत।
Not sure, sir.
हैं?
Not sure.
अरे श्योर क्या, एक जवाब दो तो बहुत सारे आ गए भाई। ज्यादा क्या हो सकता है, एक जवाब 1 क्रॉस n हो जाएगा। बताओ।
Only remain answer 1.
हैं?
N cross 1, sir.
n क्रॉस 1। बचा कौन? वैली शेट्टी, आप बताइए।
सर n क्रॉस n।
I'm very surprised to see a lot of people are saying n cross 1. I don't know. I mean, that's unrealistic to understand why you are saying n cross 1 or 1 cross 1 or 1 cross n. Whosoever got or thought over it. Answer is n cross n. Why it is n cross 1? How n cross 1 would look like? Just think in your mind. N cross 1 would be a sorry, n cross 1 would be a column vector, isn't it? So variance covariance matrix can never be a column vector. अब आप लोग समझिए कि आप लोग का एप्टीट्यूड लेवल किस स्तर का है। कि आप n क्रॉस 1 बोलते हैं लेकिन उसको विजुलाइज नहीं करते हैं कि वो कैसा दिख रहा होगा। n क्रॉस 1 ऐसे ही तो दिखेगा। तो अगर ऐसा n क्रॉस 1 दिखता है तो LA, LB और V इन दोनों में क्या डिफरेंस होगा? कुछ नहीं, तो सेम हो जाएंगे फिर। आप लोग हवाई उसमें यात्रा में चल रहे हैं अभी, रियलाइज नहीं कर रहे हैं कि जो मैं बोल रहा हूँ उसका क्या मतलब है, वो कैसा दिख रहा है। Variance covariance matrix can never be any other thing than the square matrix. Can never be. That is why I ask from one by one. Otherwise, if I won't ask, I would just understand everything is very much clear to all of you. Now, 80% of the students are not properly answering. आप लोगों को मैट्रिक्स लिखना भी नहीं आता है अभी। अदरवाइज ये आप जवाब कभी मत देंगे जिसको आप बोल रहे हैं n क्रॉस 1, क्योंकि आप लोग मैट्रिक्स को विजुलाइज ही नहीं करते। n क्रॉस 1 कैसा दिखेगा, 1 क्रॉस n कैसा दिखेगा, 1 क्रॉस 1 कैसा दिखेगा। चलिए, ये ना ऑफलाइन क्लास में डिजास्ट्रस परफॉर्मेंस रहती है कि आप लोग सब छुपे रहते हैं। यू जस्ट बिहाइंड ए विंडो। I cannot see your copies, what you are writing. I cannot see what you are, I mean, following, how much content you are grasping. But, that is our worst experience. The online classes, solution, it is not solution. The classroom teaching has no alternatives. चलिए, next one by one बताइए, what would be the size of sigma LB? शुभम बताइए। शुभम बताएंगे
सर n
सबसे पहले।
n क्रॉस 1।
शुभम बताइए। शुभम।
Yes, n cross n.
n क्रॉस और तेज बोलो यार, घर में तो खाना ना मांगते हो तो एकदम जबरदस्त बोल देते हो। और जवाब भी दे दो अच्छे से, बताइए।
सर n क्रॉस n।
n cross n. I hope everybody is okay with it because the vector size is n cross 1. That's why its size is n cross n. Similarly, the vector size of LA is n cross 1. So the size of this would also be n cross n. अब मुझे रुचि बताएं, what would be the size of sigma XA XA?
सर 1 × 1।
फिर वही बात,
1 क्रॉस n
अभी
सर।
मैंने क्या बोला? अभी थोड़ी देर पहले बोला आपके एकदम, कहाँ बैठे हैं आप लोग भाई? इस वेक्टर का साइज क्या है एक्स का? पहले ये बताइए रुचि, इस वेक्टर का साइज क्या है?
सर 1 × n।
ये क्या, कहाँ, अभी बताया ऊपर। सुमित बताइए,
सर इसका साइज,
इसका साइज कहाँ है? ऊपर बताया था आपको,
सर
क्या
n
है
क्रॉस
साइज?
1।
कहाँ, किसका साइज?
x की बात कर रहे हैं सर।
हाँ, एक्स का साइज क्या बताया ऊपर मैंने?
सर n क्रॉस 1 तो
U क्रॉस 1।
तुम लोग सब सो रहे हो भाई, हैं? अभी
सर
ऊपर मैंने
वो
लिखा इसका साइज u क्रॉस 1 है।
सर आई थॉट कि वो गलत लिख दी। सॉरी सर।
Observation and parameter may have equal size, but they cannot be represented in notation as equal. They have to be different. तो अब बताइए सिग्मा एक्स एक्स से क्या होगा साइज इसका?
U × U।
u क्रॉस
सर U × U।
यस, ये आप एकदम इसको जो we used to tell our student that please stick with the dimension. If you do not understand the dimension, you cannot solve any problem. Every time you will commit the blunders, because if you do not understand the dimensions, you cannot solve for it. So now you are pretty much aware about the sizes. Now we can start the derivation, because now you know what is the non-linear model is fxc is equal to LA. If you want to write in a vector form, it would be better not to write with a small letters. Is right, you write with a, this is the non-linear observation equation model. The corresponding linearized version is a delta xa minus sometimes, or people usually write in books as ax minus axa minus l. So better word is this. So anyways, these are the non-linear version, these are the linear version. But after that, our objective is not solved yet. Still, we have to find. Now, if this equation appears to you anywhere, you should not be confused. You should immediately thought in mind, this is u cross 1, this is n cross 1, this is n cross 1, this is n cross u, this is u cross 1, this is n cross 1. You immediately in your mind, there should be matrix dimension should come to you. Because if you do not have the matrix dimension in picture, every time you will commit errors in terms of writing the solutions. Okay. Having said that, your linearized model is available, but still your phi is VTPV. VTPV in the sense, this is, you have to minimize. This phi has to be minimized. And if you have to minimize anything, you have to go with the calculus by writing del phi by del XA, because XA is the variable which you have to estimate or optimize. Because optimize in the sense, why I'm using optimize word, because XA is being added or subtracted with the delta XA which you are estimating from here, isn't it? So XA is just iteratively getting its newer value in every iteration. Okay, that's why the correction is called as correction to the adjusted values. Anyways, so with this we have to take the partial derivative. Now you have read from in your basics that you have to understand that if you have to make a partial derivative of such a function, that x should also be a function of, or phi should also a function of x, then only you will do it. But there is no x here. Instead, phi is a function of v. तो कैसे करेंगे? कोई बताए? वो थोड़ी बहुत मैथमेटिक्स लगता हो आती हो. Please remember one more thing, which you probably, as a newcomer, would little confused with. This is a phi. इसकी डायमेंशन जरा बता दीजिए. नई एक डायमेंशन आई है. इसकी डायमेंशन बताइए. सुमित आप बताइए. डायमेंशन क्या होगी phi की?
Sir, 1 cross 1.
Yes, it is a 1 cross 1 kind of value, because it is a function value. Please remember, it is a function value. It is not a matrix. And matrix ka minimization we are not attempting here. We are attempting here the function value minimization. Please remember always. So it is an optimization function which you can think of. Okay. We are not minimizing any matrix. Instead, we are minimizing the function value. That's what I'm trying to say here. बताइए आप कैसे करेंगे डेल फाइव बाई डेल एक्स? हम बता देंगे तो फिर आपका दिमाग नहीं चलेगा. बत्ती भी तो चलानी जरूरी है.
सर वी की जगह एक से माइनस एल को
एक
रिप्लेस
लोग
कर देंगे.
एक लोग बोलो. एक लोग बोलो. आलोक.
सर चेन रूल लगाएंगे.
क्या?
चेन रूल सर. अगर
हाँ.
b is the function of x है सर.
हाँ, वेरी गुड वेरी गुड भाई. चेन रूल यही कहता है आपका कि इफ यू डू नॉट हैव डायरेक्ट फंक्शन अवेलेबिलिटी विद फाई इज अ फंक्शन ऑफ वी. अब डेल फाई बाई डेल वी तो कर नहीं पाएंगे यहाँ, क्योंकि हमें करना तो डेल फाई बाई डेल एक्स है, क्योंकि वेरिएबल हमारा ये है. तो क्या करेंगे? ऐसे लिखेंगे डेल फाई बाई डेल वी मल्टीप्लाइड बाई डेल वी बाई डेल एक्स. अब आप बताइए डेल फाई बाई डेल वी क्या आएगा और डेल वी बाई डेल एक्स क्या आएगा. एक एक वैल्यू बताइए सब लोग. चलिए सुमित बताइए पहली वैल्यू क्या आएगी. टेक योर टाइम everybody. I'll call everyone, because there is a very interesting point that is coming here, how to get the values of del phi by del v. Similarly this. बताइए क्या वैल्यू आएगी?
सर डेल फाइव बाई डेल वी का पूछ रहे हैं। सर क्लियर नहीं हो रहा है सर।
Anyone?
सर
Anyone who could give the answer?
सर डी फाइव बाई डी वी होगा 1 और डी वी अपॉन डी एक्स का होगा सर डिफरेंशिएट ऑफ फंक्शन अपॉन डी एक्स।
कौन बोल रहा है भाई? कौन विद्वान है? जरा बताएं, नाम बताएं।
सर प्रवीण।
क्या बोल रहे हो? डेल फाइव बाई डेल वी का होगा 1, कैसे?
सर फंक्शन का नाम वी के फॉर्म में है, अगर फाइव इक्वल टू फंक्शन ऑफ वी, तो अगर फंक्शन को डिफरेंट,
फंक्शन आपका ये लिखा तो है VTPV, फंक्शन लिखा तो हुआ है।
ओ सॉरी सर, हम यहाँ पे नीचे देख रहे थे।
कहीं भी देखो, FV भी देख रहे हो तो जब तक तुम्हें फंक्शन नहीं पता तो तुम डिफरेंशिएट कैसे कर रहे हो? कहाँ से मैथमेटिक्स पढ़े हो भाई? चलिए बताइए भाई, कोई तो बताइए।
सर t plus 1 v की पावर t into p.
Say again.
सर t plus 1 v की पावर t into p.
T plus 1. What is this?
Yes,
T
sir.
plus 1?
एक्चुअली सर v की पावर 1 कंसीडर करके सर वो ले लिया।
कौन बोल रहा है भाई? नाम बताएं अगेन।
सर रुचि।
आपको डिफरेंशिएशन फिर से पढ़ना पड़ेगा जा करके। वो T नहीं है, वो पावर नहीं है। व्हाट इज दैट?